Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will start a new project to look at the use of software autoforms. So what are autoforms, and what can we use them for? When you are designing a PowerBasic Windows application, you can lay out your form with controls using the PowerBasic Forms. This is a Forms Designer application which comes as part of the full PowerBasic bundle. When you decide to change your form, you load it back into the Forms Designer, make your changes, and then recompile your application. But what if we took the definition of the controls on a form out of the application and treated it like metadata? That could be loaded in dynamically at runtime. Could this be made to work for applications that were doing simple forms and allowing information to be gathered? In other words, a simple form entry system. If we could make this work, we would have a generic application that could be extended by just amending the metadata itself. Such metadata can come from a database or flat text files, giving you a very flexible system. That's what this project is going to explore. In these project videos, we'll be covering a wide range of techniques for PowerBasic. In this particular project, we're going to be creating a data entry system. But we want that data entry system to be quite generic, so that once we have created and compiled our actual application, there will be no more configuring in the application itself. All the detail of the forms will be held within external configuration files. So as you can see on screen here, we have created a blank form in the PowerBasic Forms Designer. This form only has the main dialog itself and a status bar at the bottom of the dialog. During this project, we're going to be using a number of libraries, and the first one we're going to add today is the PB File Handling Routines library. This is a generic library to allow us to do lots of operations on files. So we will add this to our source code by using the #include command. And at compile time, this library will be compiled in with our application to give us a single standalone executable. So where is our application going to get the configuration data in order to populate and to control the forms? I've created a small configuration file, testdemo.cfg. This file is going to contain the key information to create our form and to populate it with controls. The information within this file will be held in a CSV format. So I've populated the very first line to be the headers of each of the columns we're going to be populating. This config file will be passed to the application on the command line as a parameter. Therefore, you can launch different forms by merely changing the parameter which your generic application is about to receive. One of the first tasks of our generic application is to read in this config file. So let's have a look at the code. If we go to the PB main function, this is the first function kicked off when our application begins. We're going to create a local variable to hold the name of the configuration file. And we're going to populate that variable by picking up the exe path. This is the path which our executable is currently sitting in, plus the command $command. Command $ contains anything that's been passed to the application on the command line. So both of these together are going to give us the location of our configuration file. We can then test to ensure that this configuration file exists, using the isFile command. This takes a single parameter, which is the path and the name of the file you wish to determine whether it exists or not. If this returns false, then the file does not exist. In that case, we can display a message box to the user, informing them that we have been unable to find the configuration file and we can exit the application immediately. So if we get past this piece of code, then the configuration file must exist. Our next task is to load this configuration file into memory, and we're going to be loading this into a global array, and we'll be using one of the functions in the library we added a few moments ago. That's the function read the file into an array. We'll pass this two parameters, the first being the path and name of the configuration file, and the second being the name of the global array we wish to populate. So we will need to specify this array at the beginning of the application. So I'm going to declare two globals, one being the global array to hold our configuration information, and the second to be a handle for the form we're going to display to the user. So as the application runs, the configuration file will be loaded in. So we try a test compiling that now to ensure it compiles cleanly, and it does. If we have a look in the folder where our application sits, I have a subfolder called configs, and this is the one that will contain our configuration files. So we'll just change our command line parameter option in the IDE to hold a reference to this file. If we go to the Run menu and click Set Command Line, we can then populate that with configs/ and the name of our configuration file. So if we try running the application now, it will run quite cleanly and it will open up our dialog. Therefore we now have an empty dialog, and we'll want to set some configuration items up to start population. So if we have a look at the callback function for our form, the event handler, and we'll see in the initialization section is currently empty. We're going to be populating that. We need to put in here a call to a function who will populate the form from the configuration file. So we'll create a new function to perform that. This function needs no parameters, as all the information it's going to be accessing is in the global array which we've already populated. So in order to give this function something to do, we'll need to put some configuration information into this configuration file. So this is our first line of configuration. The object we wish to do something with is the dialog title. We want to set the text on that dialog title to the words first form. Additionally, we wish to set the location of the top left-hand corner of the dialog at 00. That's the top left-hand corner of the screen. We want to set the width to 500 and the height to 300. I've left a blank for the handle of the dialog itself, but the final column, the function, is to center the dialog on screen. So we will save this, and we can now put some code in our populate form function. We will create some local variables to allow us to step through the array and pull information out of that file. There are a number of ways we can actually specify which columns are which in the configuration file. We may, in a later video, use the headers at the top of that file, but for the moment I'm going to create an enumeration at the beginning of our application. This is an easy way of setting the value of constants. The first constant is going to be ref object, and we're setting the value of that to be 1. This is our first column. And the references following that will take the values 2, 3, 4, and so on. So this will specify the column position of each of the particular bits of configuration information. So going back to the populate form function, we can now enter some more code. We'll want a for next loop to step through each line in our global array. That's each line that came from the configuration file. So we're using a for next loop going from line number 1 to the upper bounding of the array. Our headers are in the 0 element of the array, so we're skipping over those. We can then take the data in each line and put it into a single variable. As we only have a title object in our configuration file, we'll do that one first. We can determine the value of our first column by using a simple select statement with a parse command. So we're looking in the strdata variable, and we're using the parse command to pull out this element. And as we saw earlier, the ref object has a value of 1. So we're looking in the first column. We're setting the case to be title, so we're looking for the title in the object column. And we want to pull out the second column. the text which we want to set as the title of the dialog. In order to know this, we need to know the dialog handle. When the form is created, it will be created with an internal variable. So let's go back to the form creation to ensure we've got this populated. At this point in the code, the HDLG variable is populated when the dialog is created. So all we need to do is to populate our global variable with that variable used here. So now that we've stored the dialog handle, we can now use it in the rest of our code. So going back to populate form, we can use the dialog set text command with our newly populated dialog handle, and using the parse command to pull out the value in the text column. So if we try running that code now, we'll see that the top of the dialog, where the title bar is, now has the words first form, which is the text we had in our configuration file. Next, we want to set the size and the location of the dialog with these additional configuration items. And we can do that quite easily by using the dialog set size command. This picks up the width and the height. If we run the application now, you'll see the dialog is indeed much smaller. Additionally, in this case, we wish to center the dialog on the screen. At the moment, the dialog is not centered. So let's put an additional command in to check to see if the function column, which is in our configuration file, is set for center or not. Currently, it is set for the word center. So we need to check that and then set our dialog accordingly. So we use the parse command again to look in the function column. If the word center is present, we want to call something which centers the window. I'm going to put a bit of API code in a subroutine to call which we can pass the parameter of the dialog we wish to center on the screen. This little subroutine will take the single parameter, being the dialog handle, and it will call the getWindowsRectangle API call and then the getWindowsPosition. The effect of running this subroutine will be to center the dialog on the screen regardless of your resolution. So let's try running that now. And we can now see our dialog is correctly centered on our screen. However, there are no objects on our dialog yet, so we need to add to our configuration file to put these objects on screen. So back to our configuration file. Say for example we want to put a couple of buttons on the form, an OK button and an exit button. And we want the OK button to perform some function, perhaps to save the data which has been put in our data entry screen, and the exit button to allow the form to be closed, and if it is the only form, for the application to end. So we will add these two lines into our configuration file. The object in this case is going to be a button, the text on the button is going to be OK, the X and Y coordinates are set, and the width and height of the button are set as well. Additionally, we're now going to be using the ID value to set the ID handle of the object to be 1200. For the exit button, we're doing the same thing for the coordinates and the size, but we're setting the ID to be 1201. Additionally, each of these configuration items has an entry in the function column. For the OK button, we're going to call it save, and for the exit button, we're going to call it exit. So if we save that, we now have to make a change to our code to handle this new functionality. So if we go back to our populate form function, we've set up something to handle title. So we now need to find a way to handle the positioning and setting up of buttons on the form. As we have the start, width and height coordinates of each of these buttons, we can pull that information out of the global array. And as we did before, we're now using a Control-Add button command with the global dialog handle and pulling out from our array the reference ID, in this case 1200, the text we want to put on to the button, the X and Y coordinates, the width and the height of the button. Now with this in place, it should display the button on our screen. The functionality will be exactly the same regardless of which button we're actually handling. So if we try running that code now, we'll see that we now have two buttons on the screen, an exit button and an OK button. We may wish to move them up slightly, but they're located certainly on the screen. However, there is no code underneath the button, nothing in the event handler, to do any actions for when you click on the button. This is what we need to tackle next. We need to put something in place that will do event handling. So as you would expect, we will go to the event handler. Normally any events on the objects on your screen will be captured within this case statement. This is for process control notifications, for example when buttons are clicked upon. So we're going to create another new function. We'll call this Run Control Processes, and we're going to pass 3 parameters to this new function. First of all is the callback handle, that's the handle of the dialog, the callback control, which is the identifier of the control that has some action being performed upon it, and finally the callback control message, which is the detail of what's actually happening to the control. So here is our new function, with its 3 parameters, the dialog handle, the control handle, and the number of the message. So we're going to create some local variables here to allow us when we step through our global array to know what we're doing. As we've done before, we're going to be using a for next loop here again, to loop through each record in our global array. We now need to pick up the object, which is the reference ID in our configuration file. This is the control number, the unique reference to the control on our dialog. We can then compare that against the number we passed in for that control, which is the one we know that has been clicked upon. If these 2 numbers match, then we have found a configuration for the object which has been clicked upon. So looking again at our configuration file, we can see that we have found a match, for example, for this number. We can now pull back this value in the object column to see whether it is a button or not. And we can then pull back the data that's in the function column to see what it is the application needs to do when this event has occurred. So we'll pull back both the type and the function. And as we did before, we're using a parse command to parse the element in the string, looking for the column number designated by these constants, one for the object and one for the function. We can then test our object type and use a case statement. So if this is a button, we can then test the type of message that we've been passed to see is it a button clicked. If the button has been clicked, we can now see which function it is we need to perform when that occurs. So if it is the save function we want to do, we can put some code in here that would allow us to perform a save operation. We'll do that one later on when we've actually got some objects on the screen. However, for the exit, all we need to do is to do a dialog end on the handle of the dialog itself. If we try a quick compile to make sure it compiles okay, and then run our application. So there's our application on screen, so if we move the mouse over the exit button and click, it will end the dialog, which will end the application. So we now have a generic configuration file which will put buttons on the screen and allow you to click upon them. Depending on how you set the configuration up, we can make any button act as the exit application button. So now that we've proved that we can put buttons on the form, can we put other controls? So let's attempt to put a label and a text control onto the dialog. So we add 2 more lines to our configuration file. One where the object is a label, and we want to put the word name into that label. We want to set its location, its width and its height, and we're going to give it a handle of 2000. A second one is going to be a text object, and we're not going to put any value into that text object. We're going to leave that blank to allow the user to key into it. But we're going to set its location, its height and width as well, and we will give it a reference of 2001. So if we save that now, and we'll need now to go back to our populate form function to put more functionality in there to handle labels and text controls. So we have entries in here already for title and button. So let's add another case statement to allow us to do labels. So for the label, we're going to be doing almost exactly the same thing as we did for the buttons. We need to pull the information out of our global array and use the control add label command. This allows us to set the ID, the text on the label, its location on screen, its width and height. Additionally, in these forms, we may want to set the colour of the label to allow it to stand out on the screen. This is something we could do later and add to the configuration file, but for the moment we'll just put it in as the colour blue. So if we try running the application now, it runs quite happily and the label is now appearing on the screen. However, the dialog itself is not particularly big and the text on the objects is quite small. However, there is a way in PowerBasic of increasing the size of the font used for the default on the dialog. If we exit that and we go back to the code. In your PB main function where we made the call to show the main dialog. Immediately before that line of code, if you put in a dialog default font. This allows you to set the default font through the whole application for each of the dialogs you're going to be using. In this case, we're setting it as sans serif, 14 point, and an ANSI character set. If we just run the application now without any other changes, we will see the dialog is much bigger, the text on each of the objects is bigger, and it is orientated better on the screen. So this is an easy way of changing the entire application with a single line of code. So now that we've got a label on the dialog, let's see if we can put a text box as well. As we set the details up in a configuration file, we merely have to go back and change the populate function. So below our command that handles the label, we need now one that handles text boxes. And this one will look remarkably similar. This time a control add text box, but the following lines of code are exactly the same. We're picking up the reference ID, the text, the X and Y coordinates, the width and the height. So if we run the application now, we will see we not only have a name, we have a text box underneath it. So with these objects on screen, we can add additional labels and text boxes quite easily. Again, without changing anything in the generic application. So we add on an extra line for a label and one for the text box. So we now have two labels and two text boxes on the screen. If we save our configuration file and then run our application once more, again a new object and its label have appeared on the screen. So we could add any number of text boxes onto the screen just by changing the configuration file. However, as you can see, there is no focus on any of the objects. If we use the tab button, we can tab around and see who has the focus. Ideally, on a form entry system, you would want the first object, the first editable object on the screen, to have the focus. So can we set that in code? So having run round the loop of all the objects in our global array, we can then check to see which is the first editable object that appears in that array, and that's the one we're going to set focus to. At the moment, the only editable objects are the text boxes and the buttons. But if we have a look in the code, we'll see the very first one is a text box. And this is the one our program is going to set focus to. So again, another for next loop. And we will pick up the object type. And in this case, we're going to be looking just for text boxes. We'll leave the buttons for later. And we can pick up the control handle number from the ID column, just as we did earlier. And we can use the control set focus command to set focus to that control. And once we've performed that function, we can exit out the for loop, as we only want to set focus to a single control. So if we try running that code now, you'll see from the name text box, the cursor is flashing, so it currently has focus. And anything you type in will go into that field. So what we've achieved today is we have taken an application which has a generic form. We have populated a configuration file with some metadata, comprising of buttons, labels, and text controls. And we've used this metadata to configure items on the screen which our user can type into. We can control when a button is clicked upon and what function we perform when that occurs. In the next video, we're going to take this concept even further. Ideally on these entry forms, You may wish to have things like drop-down lists which are pre-populated to allow the user to select from them. You may also want multi-line text boxes. And we'll also want some functionality underneath the OK button to allow us to call a function to save the information the user has entered on screen to somewhere on the system, either into a database or perhaps a flat text file. However, that's it for today. Thank you for watching.